Here we've got another equation, again with x in the index layer, and we've been asked to solve for x. I think the first thing to spot is that this is basically a quadratic in 5x. If you substitute in your mind 5x for, let's say, y, we get y squared minus 12y plus 20 equals 0, which is a standard quadratic which we can solve. So the first step is say let y equal 5 to the x. So therefore we get y squared minus 12y plus 20 equals 0. Okay, let's try it. Let's hope we don't have to use the quadratic formula. I want two numbers that multiply together to be 20, that add or subtract to 12. Well, 10 and 2 are worth a try. Y must go here, y must go there. These are both going to have to be negative because both the bottom layers must generate negative 12, which they do, and happily negative 10 times negative 2 makes positive 20. So our solutions are that y must be equal to 10 and y must be equal to 2. So our two equations become, we've got 10 is equal to 5 to the power x, and we've got 2 is equal to 5 to the power x. And the solution is to take logs of both of those equations. So doing them sort of both together, I get the log of 10 is equal to the log of 5 to the x. And here I get the log of 2 is equal to the log of 5 to the x. Log 10 is just a number. With the power law, I can bring the x down. So I get, therefore, log 10 is equal to x log 5. And similarly here, I get log 2 is equal to x log 5. Dividing through by log 5 on this equation and swapping it round, I get x is equal to the log of 10 divided by the log of 5. And here I get x is equal to the log of 2, also divided by the log of 5. Right, for the first one, and I'll quote these both as 3 significant figures, we get 1.43. And this one we get x is equal to 0.431. And that's also to 3 significant figures. And those are your answers.